In this video, you'll get an inside look at our automatic streetlight washing system and learn how to prototype your own inventions and ideas. You'll see real footage of the system in action and discover how to bring your ideas to life with minimal cost. A quick note, the voiceover in this video is AI generated, so please bear with us if there's any slight mismatch between the visuals and the audio. Over time, we'll be sharing more than 200 inventions, research papers, and ideas on this channel. I promise that by the end of the video, you'll enjoy every minute of it. But remember, the best part, the cherry on top, is reserved for those who watch until the very end. Hello everyone, I am Sunblade by Mortiza. I am an inventor, a researcher, and someone whose entire journey began in nature. I often say that nature is the greatest teacher. If you pay attention to it, you can find ideas in every corner. Today, I want to share the real story behind one of my inventions, a fully automatic IoT-based streetlight cleaning system. This is a technology that has been scientifically validated and published in Elsevier. But behind the clean diagrams and academic papers, there is a very human story, full of challenges, experiments, failures, funny moments, and real engineering. My journey started when I observed a simple but critical problem. The lenses of streetlights were covered in heavy layers of dust, drastically reducing their brightness. I realized that cities waste enormous energy because the light output drops significantly when dirt accumulates on LED lenses. I started investigating. The more I studied the problem, the clearer it became. Streetlights are one of the biggest energy consumers in cities. And yet, something as simple as dirt can reduce their brightness by up to 60%. This means wasted electricity, greater risk of accidents, shorter lifespan for the LED modules due to internal reflection and heat, and unnecessary maintenance costs. In some cities, streetlights are not cleaned even once in 10 years. Imagine that, 10 years of dust sitting on a light that is supposed to protect drivers at night. The rain hit the streetlights, and I noticed that the light didn't improve at all because the lenses were covered in heavy layers of dust. At that moment, I realized that cities waste enormous energy because the light output drops drastically when dust accumulates on LED lenses. I started investigating. The more I studied the problem, the clearer it became. Streetlights are one of the biggest energy consumers in cities. And yet, something as simple as dirt can reduce their brightness by up to 60%. This means wasted electricity, greater risk of accidents, shorter lifespan for the LED modules due to internal reflection and heat, and unnecessary maintenance costs. In some cities, streetlights are not cleaned even once in 10 years. Imagine that, 10 years of dirt sitting on a light that is supposed to protect drivers at night. So I asked myself a very simple question. Why not create a streetlight that cleans itself? After reviewing what was being used globally, I realized the existing methods were not practical. Industrial lifters are extremely expensive to rent, slow, and dangerous. Climbing robots look interesting, but they require multiple operators, depend heavily on weather conditions, and take too long to clean a single light. Foldable streetlight poles are effective, but their cost makes them impossible to install everywhere. Many older streetlights are also not designed for easy cleaning, so most cities simply ignore the problem. But ignoring it does not solve it. It only increases costs and risks. This is where I decided to step in and design something new. Most people only see the final product, but the prototype stage is where the real story lives. Prototypes are not beautiful. They are not polished. They are not made to impress anyone. They are made to prove that the idea works. My first prototype was a perfect example of this. I went to a scrapyard and bought a car wiper motor. It was heavy, old, and probably removed from a car that no longer exists. But it was perfect for testing. For the water tank, I used a simple yogurt container. For the pump, a 12-volt unit that I had from another project. I connected everything with simple wires, placed the streetlight lens on a pipe, and tested it. And yes, it looked funny. If someone had walked in, they would have thought I was building a robot from kitchen leftovers. But the system worked, and that is what mattered. From this first test, the idea evolved into two complete systems. The first system was AWS, the automatic washing system. It used an Arduino microcontroller, a water pump, a wiper motor, and the SIM 900 module for SMS control. Even at this early stage, the system was functional, robust, and it provided the essential cleaning mechanism needed to restore the brightness of the LED lights. This system was developed into a working invention and was academically validated and published in Elsevier. The second system was a major upgrade. I called it FACS, the fully automatic cleaning system. In this version, there was no need for SMS control. Everything became automated. The system used dust sensors and rain sensors to detect the level of pollution. It activated only when needed. This made the system more efficient, more reliable, and suitable for real smart city applications. This enhanced design also achieved scientific validation and publication. During development, someone asked me what happens in winter when the water freezes. This is a question many engineers have heard before. The kind of question where the person asking is more focused on finding a problem than finding a solution. My answer was simple. If freezing is a concern, then add a small heating element that activates only before washing. Not constantly. You only need to warm the water enough to allow the system to work for a few minutes. Problem solved. Many cities ignore maintenance because it seems expensive. But when you calculate the cost of decreased brightness, increased accidents, and the reduced lifespan of LED modules due to internal heat buildup, you realize that cleaning is not just maintenance. It is protection, the same way that earthing systems protect humans and equipment inside homes. And interestingly, one of my other inventions is a smart earthing system, which I built for my own research workshop. I will share that invention in another video. Throughout this journey, one of the important lessons I learned is that innovation does not need a perfect environment. You do not need a fancy lab to start. You need curiosity, persistence, and the courage to start with simple tools. A yogurt container can become a water tank. A car wiper motor can become a cleaning mechanism. None of these materials look impressive, but they carry the soul of innovation. In my videos, sometimes I use artificial voice narration. Sometimes the visuals are not perfectly synchronized. This is because I work alone on many inventions, designs, prototypes, and real-world engineering projects. My priority is always the science, the idea, and the knowledge. This channel exists because one of my professors told me that ideas like these should not be lost and that I must share them. The fully automatic streetlight cleaning system is one of my practical inventions designed for a safer, more efficient, and smarter future. Smart cities need intelligent maintenance systems. A streetlight that cleans itself means reduced maintenance costs, increased safety, longer lifespan, and more reliable street lighting for everyone. I believe that big ideas come from nature. If you expose yourself to real environments, ideas will come to you naturally. And I hope that one day, you will join this journey of knowledge and innovation. Thank you for watching, and I hope to see you in the next video. This is the final slice of the cake, and it's always reserved for those who really love learning. My goal here isn't to extend the video just for fun or to repeat what's in my papers. The real gems are hidden inside these articles and inventions, the personal experiences, mistakes, and hacks that no one can publish. If I tried to put them in a paper, it would either get rejected or people would think I'm crazy. Let me tell you a story about building the first prototype. You see, most people only see the polished version of inventions, the final product in journals or presentations. But the real fun and challenge happens in the prototype stage. This is where creativity meets real engineering, often with very humble tools. For my first test, I didn't have a fancy lab. I went to a local scrapyard and picked up a car windshield wiper motor. It was old, rusty, and completely worn out, but it had the torque and motion I needed. Then I looked around for a water tank. Instead of buying an industrial tank, I grabbed a yogurt container from the kitchen, perfect size for testing. The pump? Just a simple 12 V DC pump I had from another project. I connected everything with wires, mounted the streetlight lens on a pipe, and started testing. And yes, it looked ridiculous. A yogurt container, a wiper motor on a pipe, wires running everywhere. But guess what? It worked. The wiper moved, the water sprayed, and the dirt came off. That moment, seeing the first drops of water clean the lens, made all the struggles worth it. I even had to solve funny little problems. For example, the motor ran differently depending on the voltage, so I experimented with different settings. The water tank could be filled manually or connected to a larger urban water line. And during winter, when the water could freeze, I added a small heating element to warm the water just before operation, only for a few minutes. Nothing fancy, just practical engineering. This first prototype taught me an important lesson. Innovation is about making things work, not making things look perfect. Every piece I used, from scrapyard motors to yogurt containers, was part of the learning process. And every mistake made the final system, AWS and later FACS, stronger, smarter, and more efficient.